this video, we are looking at trigonometric identities. We have 7 of them, and the first one here, we have sine data plus cosine data squared. So you multiply them out. So using your FILE method. So sine times sine is sine squared data. So inside, outside, and last. Some of them are straightforward. I'm just demonstrating differences in technique that are involved in these kinds of questions. If you look to the top right, you'll see the how-to. And generally, there's a different technique or tip or rule for each one. So I've highlighted there, sine squared data plus cosine squared data is equal to 1. And that's your first answer there. So an exam question would be a bit more expansive than this. But it's showing just how this works. And they'll get a little bit more difficult as we go along, more or less. Next one, 1 over cosine data, and then minus cosine data. And again, you have to equate it to the right-hand side. And on the right-hand side, of course, just over, you can see one of the basic trig identities. Tan data equals sine data over cosine data. So now I'll just rewrite this. And if you're not really sure where you're meant to go with this, just think to yourself that we can't really do much with cosine data on its own. So we're going to multiply the right-hand side by another cosine. We want to get some kind of idea that demonstrates the actual trig identity itself. So 1 minus cosine squared data, and then of course it's cosine data times cosine data. So we've got the same on the denominator for each. And based on our previous trig identity, 1 minus cosine squared data is indeed equal to sine squared data. And so sine over cosine times sine, you'll get tan times sine, or just rearrange it based on the right-hand side of the identity. So we've sine times tan. So sine data times tan data. So these are the two types of trig identities you'll be using in Pure 1 in grade 11. There's about 8 to 10 basic types involving the ratio, one just there, Pythagorean, or reciprocal as well. Okay, next one. So tan x. I put in data there. So sine of x. Over cosine x. And we'll do the same to the second one as well. So plus 1 over tan x is the same as 1 over sine, in this case sine x, over cosine x. And we want it to equate to 1 over sine x cosine x. So let's simplify it out now. So plus, we're going to just invert that. So 1 over sine over cosine is the same as cosine over sine. If you're not sure how that works, just practice with another number. Perhaps 1 over 1/2, and you'll see how that works. So we've got 2 fractions we're going to multiply across. sine times sine is sine squared. Cosine times cosine is cosine squared all over. We'll just switch them around, put sine first. Cosine times sine is the same as sine times cosine. It's commutative. And now I think, just looking back over the other trig identity, you can see that sine squared x plus cosine squared x is equal to 1. So 1 all over sine x cosine x. Now let's have a look at question 4 and rearrange So we're going to change cosine squared to 1 minus sine squared, which is a rearrangement of our formula on the right. You could do it with cosine if you wish. That's why there's 2 possible answers there. So it doesn't matter which way you do it. Both of them are correct. And in this case, we can see we've replaced x or data with a. So conventions like that can change. But that's okay. It doesn't change the form or the technique involved. Next question. So here we have a funny one. We have quite a simple answer at the end. It has to equate to 5 on the right hand side. So we're going to multiply everything out. We have 2 sine data minus cosine data squared. So we have to multiply that out, as you usually do with your algebra. And the same with the second one here. It's a little bit different. We have sine data plus 2 cosine data. Again, write it out again, just to make it very clear for you. So again, using your FOIL method, it may look a little bit difficult to do, but just follow the general rules. 2 times 2 is 4. Sine times sine is sine squared. And do it out accordingly. We'll just do the first one now. The left hand side, before the addition sign. Minus 2. So the same again. And then minus times a minus is a plus, cosine squared data. Okay. And we'll keep going. So sine data times sine data is sine squared data. So we're doing the inside, the outside, and then the last again. I might just about fit this. No, not going to happen. Again, 2 times 2 is 4, and cosine times cosine is cosine squared. At this stage now, you might be able to put some parts together, so check for that. And of course, from here, underline or circle like terms and make it clear for yourself. Of course, making it clear for an examiner if you're doing an examination or a class test, but most importantly, making it clear for you doing this, and so you can follow your step-by-step process more clearly. So find your own way of doing that, and you'll make it easier on yourself. So we got 4 sine squared, and there's another sine squared, so we have 5 sine squared theta. And these 2 parts here, just make it a little bit clearer there. keep the same terms, and same with the second block there. So the parts that are green underlined and black underlined, they will go together separately, but I've circled them there, they'll go together. So minus 4 sine theta cosine theta plus 4 sine theta cosine theta. And lastly, again, just like previous first term, we have a cosine squared and 4 cosine squared. Hopefully this is starting to make sense a little bit more now. That answer of 5 only can be a little bit scary actually when you see it. So we've cancelled out those terms, and if you've just found a common factor of 5 there, you might start to see that sine squared theta plus cosine squared theta is in fact equal to 1, and so 5 times 1 is 5. That's a good question now. Now we're on question 6, the penultimate question. And what we're doing here is we're checking on the right hand side, of course. So what are we looking for? As I said at the very beginning, we're looking for sine in this case. So we have to change as much as we can and just look out for these techniques of switching things. So cosine squared y is of course equal to 1 minus sine squared y. And again, like previously, you had a or x or data, or in this case x and y. That doesn't really affect the maths involved. Just the conventions like that have changed. And I've done that for both of them, on the left and the right hand side, and then we multiply it together. Again, this question isn't particularly difficult, but it's just showing another aspect, another technique involved with these types of questions. So 1 times sine squared y is itself, and then minus times a minus is a plus, be careful. And we've sine squared x times sine squared y. And from there I can see a cancellation. And so we end up with our answer now. Sine squared x minus sine squared y. On to our last question now. Question 7. 2 minus, and then we bracket sine theta minus cosine theta squared. So the second part we actually did already. So just multiply it out using your FOIL method. So I'll just put that out there. But you can see on the right hand side, so we're equating it to sine theta plus cosine theta squared. It's intriguing because we have a 2, a constant of 2, just sitting there. So you're not really sure what to do. So this is a kind of an odd question. And so it brings in one of our trig identities. On the right hand side you can see sine squared theta plus cosine squared theta equals 1. So there's not much we can do here. So if you really can't find it, it might be something outlandish like this. So of course 2 times sine squared theta plus cosine theta would be the same as 2 times 1. And again, write out the other side. So again, these examples are not really expansive examples that you might get, but they are showing different techniques, the ways that you would do this, like using factoring, trying to manipulate your trig identities, only in grade 11. So you're just using those two Pythagorean trigonometry identities that you've seen here in this video. So now 2 times that. So 2 times sine squared minus sine squared is sine squared theta. And again, 2 times cosine theta minus cosine theta. I'm just jumping a step there, but you can see what I'm doing. And then of course left over is 2 sine theta cosine theta. And just back to our very first question, or even to a previous part we did as well, so we've done this numerous times. So of course, sine theta plus cosine theta, if that was squared, you would have arrived at this answer in a different order, perhaps. So that was 7 examples of trigonometric identities for pure 1 mathematics, AS mathematics.